Good morning, everybody. Welcome to this webinar, Product Design Manufacturing Collection, Do More with What You Have. My name is Clint Brown, and this morning I'm joined by Laura New, who is your Manufacturing Account Manager. Morning, Laura.
Morning, Clint. Morning, everybody.
All right, so Laura's going to kick off this morning's webinar with some info about Graitec. I'm going to run through all of the parts of the collection that are key for us to look at, and then we'll wrap it up at the end. If you've got any questions, please stick them into the question dialogue, the little chat box, and we'll pick them all up at the end. And over to you, Laura.
Okay, perfect. So a bit of background on Graitec for those of you who are not already aware of us. So we help manufacturing, engineering, construction and architectural professionals. Obviously we supply software, we help with training, consultancy, kind of the whole scope of services. And of course, we're a platinum partner for all products and industries. We've been around about 30 odd years. Our global HQ is in France, and we always put the customer first. So if you guys have dealt with our support team, you'll know they've got about a 98% good or excellent support rating, and we generally do everything we can to help make you guys a success. So as you'll see from today's webinar, this is what we're all about. We obviously cover the Autodesk portfolio. Today, obviously, we're focusing on the product design and manufacturing collection. And we've also got Graitec products. So for example, anyone who gets their Inventor subscription through Graitec, you will have access to our Inventor Power Pack. If you subscribe to Revit through us, for example, you'll have access to our Power Pack for Revit. And as you can see at the bottom, we also have a number of other products as well.
I'll build these out for you.
Thank you very much, Clint. This basically just shows how the Graitec products from the previous slide interact with the Autodesk portfolio to kind of create an end-to-end solution for create, simulate, fabricate, and manage. And with that, I believe we're back to Clint to show you what you all came here to see.
Fantastic. Thanks, Laura. Okay, so, we're all busy. We have a lot of us been using Inventor for years. We've probably been moved from Inventor to a, I forgot what they were called, but eventually up to a collection. And we've got all these new tools, and there's all these tools in the toolbox, and you've probably not spent enough time or had the time to go and investigate what we can do with them. So how do we spend more time innovating with the tools that we've got? Can we improve the performance of our products, but also our designs? Can we get more out of our machines, or maybe our suppliers' machines? And can we do things more efficiently, and be that factory layouts or design in general? So Laura alluded to these earlier. Autodesk have 3 different collections. The one on the right-hand side, the Media and Entertainment collection, is used by the film industry. The AEC collection in the middle is used by architects and people who build things. And on the left, my personal favorite, the Product Design and Manufacturing collection, used to make things. So the thing we really want to consider is we want our data to be the key to everything we do. So change made anywhere should happen everywhere. And there's some really good tools in the Product Design Manufacturing collection to help us achieve that. So we've got generative design tools, mechanical design tools, simulation tools, CAM tools, and really good tools for creating marketing content. Now, at the heart of the Product Design and Manufacturing collection is Inventor. Inventor is our hero product. And Inventor does a bunch of things really well. So for instance, electromechanical design, mechanical design, we have Nastran simulation, tolerance analysis, nesting, subtractive CAM, sheet metal rendering, manufacturing drawings, tooling design, factory layout. On top of that, there's other things like iLogic for design automation, tube and pipe, frame analysis, frame design, etc., etc. Inventor is an incredible tool that's really broad and covers a lot. But part of the collection as well is AutoCAD. And with AutoCAD, we get 2D design and factory design as well. In addition to that, we get Navisworks, which allows us to do design review. So you could bring in massive models and bring them together. You could even bring in, say, a Revit model with an Inventor model, and you could put them together and you could interact with the model. Reality capture through Recap allows us to bring in point clouds and to edit those point clouds. 3ds Max for marketing content. And I'm going to show you some things that came out in 3ds Max last week that are really useful for Inventor users that are using scanned data. In addition to this, we also get access to Fusion 360. So Fusion 360 is cloud-based, and we get a few additional tools like cloud rendering, electronics design, additive and subtractive CAM, and generative design. So different ways of getting to our final design. And to wrap this all together, we get Vault Basic in the box, and that's our data management tool to make sure that everyone's working on the same piece of information. So another way to visualize the product design manufacturing collection is to just look at the individual products like this, but obviously there's a lot to them and a lot of interoperability and different ways of working as well. So let's dig in. Let's have a look at these individual things. So first off, we now have end-to-end workflows inside of Inventor. If you've been using Inventor for a long time, you'll remember 10 years ago, for instance, Inventor was a little bit of a silo. It now works across a whole load of different places in manufacturing. We can now do advanced nonlinear simulation with Nastran and CAD. We have the ability to do 2.5 to 5 axis CAM. We can do sheet metal nesting. We can do tolerance analysis, and we can do factory design, all inside of the one tool set. AutoCAD's changed as well. So, you know, Inventor has always pretty much come with AutoCAD, but we now have AutoCAD with architectural tool sets, electrical tool sets, mechanical tool sets, Plant 3D, Raster Design, Map 3D, and MEP. Now, for most mechanical designers, there's a couple of things in here that are really useful. We're going to touch on the electrical tool set in coming up in the next few slides. The architecture tool set's actually used for factory layout. We'll see that. My personal favorite out of all of these is the Raster Design toolset. So you'll know that you can open PDF files inside of AutoCAD and actually get all the layers through if it's a rasterized PDF. But you can also use the Raster Design toolset to rasterize PDFs that might just be lines that aren't on layers. So effectively, you can pull data out of them, or from a scanned image file, you can actually pull lines out and use that data again. So it's a really good way of getting data from old files or from drawings that have maybe been lost. All right, but better than that, we can actually reuse our AutoCAD data inside of Inventor. So if you've got legacy data or old data lying around or something that you need to turn into 3D, we've got the tools in Inventor to do this. So let's have a look. Here's an AutoCAD drawing, and we want to place this component into Inventor. So inside of Inventor, we're going to create a new part, and we're going to place that AutoCAD data directly in through an import. So we're going to import in the AutoCAD file, and we're going to place it inside of our Inventor model. Once we've done this, we can choose which pieces of the geometry we want to project over. And once that's done, we can now start doing Inventor modeling. So here we're going to do a revolve. We're going to go through and choose all the profiles that we need to create some geometry. I'm then going to select a center point or an axis, and I'm going to revolve that data. Once I've done that, we can add some extrudes to remove some of the information that we don't need on the revolve. You'll see my part really starting to take shape quite nicely over here. Remove a few more pieces on the middle there, and I now have a really good looking turned component over here. We can go in and use the same AutoCAD data. And in this instance, I'm going to just place these holes on the back end of the shaft over there. And again, using my project geometry, I can go and grab the center of that hole. And then I can use the new hole tool to go and place these holes on top of that sketch, use a circular pattern to put them in place. But as you can see, using that AutoCAD data, I've now created this component, which is great. I can then apply material, and really quickly I'm there. Now, what happens if I want to make a change? Well, here we're going to go and stretch this component, so effectively making it longer inside of AutoCAD. I'm going to hit save, and as soon as I hit update in Inventor, that's changed in the 3D model. So using any CAD technology, we've updated a 2D AutoCAD drawing, and our 3D Inventor is updated. Really powerful. So we spoke about these specialized tool sets, and for electromechanical design, we have AutoCAD Electrical and Inventor as part of the collection. So what does this look like? Well, here's AutoCAD Electrical. You can see I've got my wiring diagram. And what I'm going to do is I'm just going to add a new wire in over here. So we're putting in a wire between our cage connector at the top and at the bottom over there. I'm now copying over the switch that you saw on the right-hand side. And I'm going to rename the switch so that we know this is our engine on off. I'll say okay. You'll see that AutoCAD Electrical's intelligently trimmed back those wires for me on the switch. We've just recolored that wire over there. I can run through and automatically renumber all of my wires, and I'm going to hit save. You'll notice on the left-hand side, I have an electrical browser, which I can sync to Inventor. So now we can shoot over to Inventor. That same browser is available, and I can now insert that switch that we copied into my 3D design. I'm going to place that in. You'll notice the blue harness in there that we've created previously. And what we can now do is we can wire this up. So we can actually connect our switch to the rest of the wiring. And here we're going to go and route the wires through that harness. In we go. Now, because this is bidirectional, had I added the switch in Inventor, I could have synced that back and added it back into my 2D schematic in AutoCAD Electrical. So you've got a really good workflow between 2D and 3D. And again, from here, we can then understand things like harness length, etc. Fantastic tools have been added for design collaboration. So if you've seen design shares, you'll know that these are very powerful. This is what they look like. So inside of Inventor, I can go and create a design share, creates a shared view for me, give it a name. Web viewables are created, so you're not actually sharing the data, you're sharing a web viewable version of your data. This is what the data looks like when it's shared. So this is viewing the same Inventor model inside of Chrome. So the idea here is that you could share this data and you could access it on practically any device connected to the internet. We're able to move the model around. Here you can see we're doing a measurement. But you can start understanding the power of this. So internally, you could share your model with production, or you could share it with a customer for approval, or with someone that you're collaborating with, maybe on materials or design, whatever it might be, but directly from Inventor, just by going share design. This is using Autodesk's large model viewer. So you can see that we're able to do things like explosions. Here we've hidden a component, and I'm about to do a markup. So we can go and add in arrows and text. And once we save that, that markup is available inside of Inventor. So if we go back into Inventor and we refresh our shared views, you'll see that a comment's been made on the shared view. We're able to click on it to see it, we can resolve it, and we can go back and forward on that without leaving Inventor. So what's next? Well, third-party data referencing, or what we call AnyCAD. Inventor can reference in files from CATIA, SolidWorks, Creo, Pro Engineer, Solid Edge, NX, STEP, Revit, etc. And the beauty of this is that unlike the old days where we had to translate data, we're now referencing that data directly in, meaning that if the source data is updated, it just updates inside of Inventor. We don't have to re-import and do those steps that we used to do for years and years. So what does it look like? Well, over here, we're going to import a third-party CAD file. This has come from SolidWorks and place it into our Inventor model. And we haven't done any conversion. We've just used AnyCAD to place it in place. Now, Inventor model has 4 bolts sticking out, and the SolidWorks model has 3 bolt holes. So using a design share, we're going to explain this to the SolidWorks user to say, hey, we need to change your design to match our 4 bolt holes. So the bottom right there, you can see the SolidWorks going. They're going to go and change from 3 to 4 bolt holes. Once they've finished their clunky design, they're going to hit save, and their model's going to be saved. So now inside of Inventor, all we need to do is an update. So we click update, and their model comes through, and we can now reference those changes. And we're then able to do normal modeling, things like mates, etc., and those will go in. And Inventor will remember our mates and any changes that we've made based on that geometry that we've used AnyCAD for. All right. What about data management? Well, at the top of this, I mentioned that Vault is used to manage all of this data, and we can easily track all of our project data. But Vault's got some really useful use cases out of the box that we should look at. So first off, really intelligent search. So here I'm searching for a bushing, and I can then search on material. And this is going to go through Vault and look at everything that I've got. So here I've found this bushing 500 ID. I can see where it's used, and I can find this top level assembly. I can go to that assembly. I can see its history. I can see a preview. Inside of Vault, you can preview any file. And here we can actually interact with the file without opening it. So we can actually see a bit about it. I can see what it uses, as in all of the components that are used to make it up. And we can also do copy design inside of here. So the copy design tool allows me to make a copy of an assembly really easily, and it'll remember all of the links. But better than that, I can actually go through and copy some components, but reuse others. So I want to reuse all of the standard components. So what you'll see on the left-hand side over there is that I'm now copying all of the components that are in bold, but reusing the ones that are not. So that's copied. The text there are the components that have been copied. And if we go look at the folder that I've copied this to, I now have my copied assembly. We create a quick shortcut, jump into Inventor, and we can open this up. Now you'll see that this copied assembly just resolves perfectly because Vault's rebuilt all of those links, and I'm now able to open and interact with this assembly, and I can make any changes that I would need to do in a normal Inventor workflow without affecting any of the other components. So copy design, gold standard in Vault for making copies of large assemblies. Right, moving on to one of my favorite topics, design automation through iLogic. So we can save time configuring designs to fit customer requirements. We can institute rules-based design. The idea of that is that you can start creating product configurators where you put intelligence into the model based on engineering. So if the maximum manufacturing width is 1200, you can't exceed that and your model will be corrected, meaning that you can't specify something that can't be made in your factory, for instance. You can also use iLogic to automate tedious tasks as well. Here's a quick example. So if we have a look at this concrete skimmer, we have a configuration that we've set up. You can see we can choose width of the spider, width of the machine, we can choose a color, and we can choose a motor type. We're going to apply that. Because the width is exceeded, we need to increase one of the thicknesses, no problem. All of our data is going to be pulled out of Vault. That's going to update. And there's our yellow skimmer, different size with its new motor applied. Again, our drawing will update and all of our dimensions will be correct as well. What about simulation? Well, Inventor has a few different simulation options. One of them is Nastran and CAD. Nastran was originally developed by NASA in the 60s for the development, in the 70s for the development of the space shuttle. And this is what it looks like inside of Inventor. So here we can go in, we can apply some constraints, add in a connector. So imagine a pin that would be going through the top of that shaft. And we can then apply a moment load to that shaft effectively, so 500. And we can then go through, set up our mesh. And once our mesh is created, we can then simulate that moment on these components. So here we go, run our simulation, and you can see how the stress distribution is shown on the model through this animation. And that's just one use case, but there are loads of use cases for Nastran and CAD. So if you've been using Inventor simulation, you'll know that there's these sort of 4 or 3 types we can use. Nastran adds a whole load of additional simulation capability to Inventor. So for instance, if you want to do drop tests or other popular types, so these are the most popular use cases. So frame analysis on the top left for thin materials. Bottom left, we can do fatigue analysis, top right, thermal stress, and bottom right, buckling. So if you need to understand buckling of your components, Nastran in CAD. If you want to understand fatigue, well, what happens if we run this through 10,000 cycles? Will it break? Fatigue analysis. So you'll see that there's some really, really powerful tools available, and these are just in the box with the collection. Something else that we have is model-based definition. So model-based definition is there to start communicating dimensions on top of a 3D model. So rather than a 2D drawing, sometimes it's quicker to add dimensions to a 3D model and to share them. We can do things like share dimensions, tolerances, and surface finishes. And the good thing about this is we can then share that via 3D PDF or DWF, or via the Autodesk viewer, and even via step AP242. So meaning that we can export a step file, and someone who has the ability to read a step AP242 file will actually be able to see those dimensions. So here you can see we've got a bunch of dimensions. I'm adding in a tolerance over here. There we go. And when I'm happy that all of my dimensions are okay, I can export this. So this is going out to a shared view, but you'll also see the options next to that for DWF and 3D PDF. So here's the model in the Autodesk viewer, and I can see those dimensions. And again, just like before, really easy to share directly from Inventor. Speaking of tolerances, we have a new tolerance tool. It's been there for a couple of releases, but we now have the ability to do a 1D tolerance stack up. So if you've ever had to do tolerance stack ups where you've had spreadsheets and difficult drawings, it's now really simple. Here you can see we're looking at a worst case scenario. We can move through each of our dimensions. As you see, as I click on them on the right-hand side, they're highlighting green on the left. And I can make tweaks to my overall tolerance, and I can see how it affects the stack up down the bottom over there. And then I can look at worst case, RSS, different statistical models, and I can get a real understanding of what's happening with my model. And again, I can then look at that in the assembly as I go. So great insights for people who need to understand their tolerance stack ups. Now, at the top of this, I mentioned 3ds Max, and I mentioned some of the new stuff. But just remember that in the box, you get 3ds Max. And 3ds Max is a phenomenal tool for doing rendering. So these are some product renders from 3ds Max. But it's not just about product renders. You'll see down the bottom left-hand side, we can do really complicated animations. And up the top right, some of the new features around blooming in lights. So you can see that over there. We can enable bloom. But one of the big features that was recently announced, as in last week, for 3ds Max 2020.3 is the new retopology tool. And what this allows us to do is to create lower resolution poly or quad models. So you'll see that we're looking at a very complex mesh, and that's then sent through retopology, and we get a much more usable mesh. So if you are doing laser scans of components and you're trying to bring them into Inventor, this is a tool that'll really help you. So here are a few more examples. This is sort of angel statue. You'll see on the left and the right, those are the same models, just with their edges shown. So the component that, or the angel that looks like it's all red, that's the mesh from the scan, really complex. And the image next to it is the same mesh once it's been run through retopology. So a really good tool, and something that people who use laser scans will really find useful. It's also quite fast when compared to other technology that does similar things. All right, integrated CAM. So Inventor comes with integrated CAM, and we can do turning, lathe milling with 2.5 to 5 axis machining. We also have adaptive clearing, and there's a CNC editor. We can do probing, setup sheets, simulation, and verification. So this is what it looks like. Here we have a component inside of Inventor, and we're going to set up a milling operation. From here, we choose a machining strategy, and we go and add in the different operations. So we're doing a facing operation at the moment. We can choose our passes, so we can sort of set that to a 40 millimeter step over, and our toolpath's generated. Next, we're going to add in some 2D adaptive clearing. Again, choose the geometry we want to affect and our linking, etc. And off it goes. So with all of our toolpaths created, we can simulate what it's going to look like. You can see we're actually removing stock as we go through there. Next, we're going to do our 2D adaptive clearing. You'll see that we're using, we're getting a full simulation as we go through. We can see how the material is going to be removed. And once we've done our design and our initial machining, what happens if something changes? Well, the best part about this is being parametric and being part of Inventor, everything's in the same place. So if we go back to our machining, it's just a matter of updating our toolpaths, and all of our toolpaths will regenerate with those new sizes, which is great. So from here, we can do post-processing. So we can post our posts out, and we can see our G-code in the G-code editor. We can also create setup sheets, and this will show us all of the tools that are going to be used in our different operations. It'll show us our feeds and speeds, and how long each operation will take. So in another vein, we have the nesting utility. So if you create sheet metal components and you're interested in nesting them, we now have a tool for that as well. So if we take this assembly, we can go and create a nest. This will go and find all of the sheet metal components in that assembly and bring them into the nesting environment. And what we can do from here is we can create a nest, and it's going to go and put components of the same thickness into their own nests, as you can see over there. So if we look at the one down the bottom over here, we can go into the nest, so nest number 6, and we can go and look at the nest itself, look at its properties. And maybe we want to grab one of these small brackets and say, well, rather than 6, add 55. It'll re-nest that for us. You'll see some of those smaller brackets have now been moved across to the right. So we just want to go and look at the properties again, and we can change our item separation from 8 millimeters down to 5. Our nesting optimization will improve, so it's now at 75% where it was in the 30s before. All of those brackets now fit, and we've now got a usable nest. So from here, we can do a few things. In this instance, we're going to go and create a 3D solid. And with that solid created, we can now go into the CAM environment again. And similar to the milling that we did before, we can set this up to be laser cut. So we're just going to choose an origin point. We're going to tell that we want to cut this out. And then we're going to do a 2D profile. You'll see we've got the option of water, laser, or plasma. We're going to choose, we've chosen laser, choose the edges that we want, and we can then simulate the laser cutting this out. Now, I didn't need to do a 3D model. I could have just exported a 2D DXF of that directly out, and you can send that straight to a machine. But it's really nice to see that we have these tools available directly inside of Inventor. So there we go. There's our laser cutting out our nested file. In addition to that, we have our factory design utilities. So factory design is really good for laying out factories, but you could use it for all sorts of things. So I've seen this used for designing kitchens, designing classrooms. It's just a way of intelligently laying out 2D and 3D assets to get to your design. So the first tool you get with factory design is our process analysis tool. And this effectively lets us lay out components. So you'll see down on the left-hand side, we've got a browser full of assets, and we can go through and set these assets up. So we can put them in a logical order. And once we've put them all together, we can start looking at how long it takes to move something through our virtual factory. We can start understanding the efficiencies of our production line. Once we've done that and we're happy, we can generate reports. We can see how things are going to perform. And then we can create a 2D DWG as well, which we can then look at inside of AutoCAD. You'll also see the same browser, this time on the right-hand side, with assets inside of it. And we can do things like add in conveyors. So here you'll see I'm adding in a conveyor between these two components. And I can then convert that to an asset. It puts it in, and we can then save this and sync back to Inventor. And inside of Inventor, that 2D layout is going to become 3D. So you can see our factory in 3D over here. And we can then place assets again, the same asset browser. And this time we're going to look at robots. So we're going to place down a robotic stand, and then we're going to place 2 Fanuc robots on top of it. And we'll snap the one into place, and then the second. So what you'll notice with factory design is that we can sort of snap these components together. We can draw in 2D, they become 3D, and we use the power of Inventor to look at these. We can also then start looking at using Navisworks. And inside of Navisworks, what we can do is we get a first-person view, so we can interact with our model, and we can include even more geometry. So in this example, we've actually got our entire Inventor factory, as well as a 3D model from Revit of the structure. And what we're going to do now is a clash detection. So we're actually going to go in and we're going to do a clash detection between our Inventor factory and our 3D model of the structure from Revit. And you can see that we found a clash. So from here, we need to look at moving our factory floor, probably moving this production line over here over a few millimeters so that we no longer clash with the structure. But that's not all. There's even more. What about cloud-based workflows? So we spoke about Fusion 360 coming in the box. Fusion 360 gives us a bunch of additional tools. So let's jump in and have a look at what we get. One of the impressive things is generative design, and you've probably seen generative design and wondered how you could use it. Well, generative design has been evolving quite a lot. So there's a nice case study from General Motors. You can see where they've taken the seatbelt bracket from 8 components and they've consolidated it down to 1, where it's 40% lighter and 20% stronger. Generative design looks like this. So the way it works is you have 3 things to look at. First thing being preserve. So geometry that you actually want to almost reuse, which you would preserve. You can then set obstacles, so places that you don't want any new geometry to appear. And you then apply loads. So in this example, we apply loads to the bottom of where the swing arm would be. And generative design goes away and builds a component to fit that space. So it can create hundreds or thousands of different design variations. And once it's gone through and chosen or created all of these, you can then go through as the user and filter them out to choose the best options for your design. You can then place them into the model. So another way of looking at this, here we've created a bunch of different options, and we can eventually go and choose the one that we want based on the material and the manufacturing, etc. And from Fusion over here, you can see that this model goes straight into Inventor, and we can interact with it in the Inventor model. Now, traditionally, these components were really alien looking. So if you look at the additive manufacturing over here, you really needed a 3D metal printer to take advantage of this. But this technology has moved on in leaps and bounds. We can now do CNC milling. So we can create outputs that are millable. And I'll show you a nice example of some of the new stuff where we can now create 2.5-axis milled components. We've also got options for creating castings and even injection moldings. So this is an example of what a 2.5-axis milling output looks like with tool accessibility. So it actually understands that you need to get a tool in and out of specific areas, but it will start generating these shapes that we can actually mill. And it also creates them with geometry that you can edit. So we can actually go in and edit the size of that pocket, for instance. So the technology's moved on in leaps and bounds, and it's really useful now. You know, you don't have to 3D print everything. You can start machining as well. And then for anybody that creates electronic designs, Autodesk bought a product called Eagle several years ago, and this has now been integrated into Fusion 360. And we can do all sorts of things from electronics cooling to spice simulation, all of your PCB layout and the machining as well. It comes with a huge library. It's just a really interesting tool, and it's available as part of Fusion 360. All right, so you've seen a heck of a lot. I've spoken about all sorts of things, and I didn't even cover everything that's in here. You know, we can still do things like sheet metal inside of Inventor and actually fold up components. There's tube and pipe, there's frame analysis, there's the design accelerators. There's just so much inside of here. And what we really wanted to highlight was some of the things that are inside of the collection that might not be immediately obvious to you. So hopefully that was useful and you've seen some interesting bits. All right, so if you've got any questions, you can stick them into the chat and we'll answer them now. Otherwise, you know, feel free to reach out to us after this. I'm going to stop the recording now